Hello friends, I am Aditya Bhavne. Today we are going to learn force exerted by jet on moving flat plate and stationary inclined flat plate. In earlier lecture we studied about the force exerted by the jet on fixed vertical flat plate, in which we studied whenever the water jet strikes on a vertical flat plate which is fixed, and its initial momentum whenever it strikes to the plate at the striking position, that is final momentum, becomes zero, and the force that has been calculated by the formula Fx equal to rho a v square, and that can be derived from momentum equation, that is initial momentum minus final momentum. Fx equal to initial minus final momentum. Now let us study the force exerted by the jet on flat inclined plate moving in the direction of jet. So let us assume that velocity v of jet striking to the plate and the vertical plate which is moving at u velocity. So this is absolute velocity of jet and u is the absolute velocity of this plate, vertical plate. Now whenever this jet strikes to the blade or plate, it will move with this two velocity, that is nothing but a relative velocity comes in picture. So what is concept of relative velocity? If we are moving by, let us example, if you are moving by two bicycles or two motorcycle in the same direction, you will assume that both are stationary if we are at same speed, and if we are moving in the opposite direction with different speed, then your speed will get added. Okay, so that is nothing but relative velocity. Whenever we transfer to train or travel through train, when another train crosses with same speed, but what we assume, that train is having higher speed than us, but that is not the case. Whenever two trains crossing each other with different speed, their speeds get added up, and when two trains are been moving in the same direction, then their velocities will become subtract. Okay, so in this way the velocity of this jet and blade are moving in same direction, so relative velocity will be v minus u. This is v minus u, so the relative velocity will be v minus u. And what we know, we need to find out the force, and that force can be found out by using impulse momentum principle, and that is nothing but force equal to initial momentum minus final momentum, which is equal to m dot in bracket initial velocity minus final velocity. Now in this case, what is initial velocity and final velocity? So initial velocity will be when the jet was striking to this plate, that is initial velocity, and when it strikes, its final velocity becomes zero, and with relative velocity it will move forward. Getting? So it will move forward. Now what is the mass flow rate per second for this case? We know mass flow rate is nothing but m dot rho a v, so equal to rho and area of jet, so area of jet and velocity of the jet striking the plate. So velocity of jet striking the plate is nothing but relative velocity. Whenever it strikes the plate, relative velocity comes in picture. So final force exerted by the jet moving in the direction of jet, so along the direction of jet is x direction in this case, so that will be, I can say, v minus u. So force equal to mass of water striking per second into initial velocity with which water strikes minus final velocity, so equal to rho a v minus u in bracket v minus u minus of 0, since whenever it strikes final velocity becomes 0 as we know earlier. So Fx equal to rho a v minus u bracket square, so v minus u into v minus u bracket square. Now in this case, as the plate is moving, so there will be some work done. I mean, previous case when the plate was fixed, there will be no work done since the plate is fixed, so plate is not moving, so work done will be 0. In this case plate is moving, so there will be work done. Now how will we calculate work done? Work done equal to force into displacement. Now work done per second, so force per second into distance. So this distance traveled. So we know force is Fx along the direction of jet, and distance by time is nothing but velocity. Now in this case the blade is moving, so that blade velocity is u. Now if you what is the SI unit for this case is nothing but Newton meter per second or joule per second, or I can say watt. Okay, so work done per second is equal to rho A V minus U bracket square into U. Now next case, that is inclined plate. Earlier we studied flat plate, that is vertical. Now in this case the plate is inclined. So plate is inclined. Again let us assume that this is the velocity of jet. Okay, this is fixed plate, so u will be 0 and its inclination is angle theta. So angle, this will be theta, so this will be 90 minus theta. Okay, so 90 minus theta, getting? So along x direction, so whenever velocity will strike to this plate, it will move along upward direction and downward direction, getting? So next, so here the picture will get cleared. Whenever jet strikes, the velocity or flow will move in upward and downward direction. So the component, this will be theta, so 90 minus theta. So this will be 90 minus theta. So Fx, so V sine theta along x direction. Okay, and which is normal to this plate. So V component, that is normal component of force, is nothing but V sine theta for this plate. So what we are assuming in this case, whenever jet striking to this plate, the plate is having smooth surface, so there will be no loss of velocity from inlet to outlet. So whatever velocity will strike to this plate will remain same at inlet and exit. So let us find out the normal force. Normal force will be mass of jet striking per second into initial velocity minus final velocity. So initial velocity of jet before striking in the direction of normal, that is in this direction, normal to this plate, and final velocity of jet after striking the plate. So we know normal force is V sine theta, and whenever it strikes this normal force, it will not move along this direction as plate is stationary. So that velocity V2 will becomes 0. So Fn equal to rho a V in bracket V minus V sine theta minus 0 as final velocity becomes 0. So final equation Fn equal to rho a V square sine theta. So now this final force or normal force can be resolved in two directions, that is x and y direction. So let us calculate Fx and Fy. So force in along x direction, that is component of Fn, can be calculated as Fn cos of 90 minus theta. So Fn cos of 90 minus theta, getting? Along x direction. So what is cos 90 minus theta is nothing but sin theta. And what is Fn? Fn is rho a V square sin theta. So final velocity, or sorry, force becomes rho a V square sin theta. Similarly for Fy, so force along y direction will be component of Fn perpendicular to the flow. Component of Fn perpendicular to the flow will be Fn sine of 90 minus theta. So this angle sine of 90 minus theta. So along x direction and along y direction. So which will be Fn cos of theta. So rho a V square sin theta cos theta, as Fn is rho a V square sin theta. So from this, or I can say resultant force, that is Fn or normal force, will be equal to under root of Fx square plus Fy square, that is Pythagoras theorem, hypotenuse square equal to this square plus this square, adjacent side square plus height square. Now one more question may arise, what about the discharge or discharge ratio? So whenever total amount of quantity striking on the plate, it will get divided into two parts. So if this is moving with particular quantity q, let us say, and it will divide into q1 and q2. Okay, so now how we get the discharge ratio? For that we are applying impulse or momentum equation. So initial momentum along x-axis or axis of the plate will be equal to moving in two directions. So this will be in and this will be out. So m, we know momentum is nothing but mass into velocity. So total momentum equal to momentum 1 plus momentum 2. So that is mv total equal to mv1 plus mv2. Now what is mv or m dot? That is nothing but rho av. So av is nothing but discharge. So rho into discharge, and v is v cos of theta. So v cos of theta along x direction. So we know that. So along x direction it is v cos theta for plate. So if we get this, along the plate is nothing but v cos of theta along the plate. And for q1 and q2, that is q1 rho v and q2 rho v. Now in this case we assume that there is no loss, which means v will remain same. So v will get cancelled and density of water will remain same, so density will get cancelled. So what remains as q cos of theta equal to q1 plus q2. Okay, q1 plus q2. So consider this as question 1. Again we know that total quantity in equal to number of outlets. So that is q1 plus q2. So if I add this to q1 plus q equation 1 and 2, what I get? So q2 will get cancelled. q1 plus q2, that is 2q2, and on the other side q plus q cos theta, q plus q cos theta. Now next 2q1, that is same question, 2q1 equal to q cos of theta plus q. Now q1 equal to q by 2 in bracket 1 plus cos of theta. How it comes? Q is taken common, so 1 plus cos theta will remain, and this 2 will go to this side. So similarly, if we subtract equation 1 from 2, we will get q2 equal to q by 2 in bracket 1 minus cos of theta. So if we take ratio q1 by q2, what we get? q1 by q2 equal to 1 plus cos theta by 1 minus cos theta. So it will be fine for ratio q1 by q2 equal to 1 plus cos theta by 1 minus cos theta. Thank you.